point, we'll start going over some of your questions for the oil burner exam, oil heat efficient exam. So fuel pump and igniters. We were able, hopefully you remember, that last semester we did install a pump, bleed a pump,
Oh, yeah.
diagnose the pump, change the pressure. So we will use that information now. Hopefully, did not forget completely. And do not forget to tighten the nozzle line.
Or it'll come off everywhere.
Yeah, we had that a few times. So the pump has a strainer. Some pumps have a strainer, some of them don't. If it does, take it out and clean it, wash it. It would have some debris in it. There's an oil filter or a fuel filter. That actually, it's a good practice to have in every burners. We do not have that here. We have it in the main line, which is not a good practice. We should have them in every tank, because now we have one big main tank. But in reality, you want to have, if you have one burner and you have one tank, you should have it coming out of the tank as an oil filter. And the oil filter is almost universal. So every year you want to change that filter, kind of like your oil filter in your car. If you change the oil filter and you find some sludge in it, some unrecognizable material, you better check the tank. Make sure what's in the tank and there's not a lot of water inside the tank. How do you check for water inside the tank? Where's the water going to be? Top or bottom? Bottom. Because oil is lighter than water, so it's going to be in the bottom. So how are you going to check for that? You can't do it visually, right?
Was it low cut valve?
No.
Does it have a little plug on the bottom and you kind of open it for a little bit into an open container and see if there's water in it?
There's a way you can flush it, but this is not how you check. If you have to be creative, how would you do to check that?
Put a tube down into the bottom of the tank,
When
and
you get
use a hand pump to pump it up and watch the water come up
Close.
until it turns to oil.
The stick is a close idea, the tool. So the most common way now that we use, there's a paste that you put in a wood stick
Oh,
and you stick it to the bottom of the tank. And this paste will react with only water. If it changes color, I have the paste here, but we don't have water underneath the tank. If it changes color, then there's water underneath the tank. Now you know if there's water, you're gonna have to drain the tank or look for the, if it has been, take it out. and flush it.
There's a big problem with that.
Why?
How tall are your ceilings? Or how tall are ceiling in the basement?
You can use a rope. You can
a
use a
rope.
sausage-like stick with pieces, like links.
Okay.
There's a problem with that also with water tank when you want to change the sacrificial rod. Okay, you're right. Okay, the tank is here. How I'm gonna stick that hole?
Yeah.
Stick it there. Yeah. So you can get creative, but the paste is the main idea. Get that paste, and you put it in a stick or like links of sticks, and drop it in there, and check if there is water or not. And usually there's not a lot. It may be like 1 or 2 inches tops, even half an inch. But again, the water will feed the bacteria. Bacteria will feed on the oil. I will have sludge and stuff like that you don't want. Regulator valves. That's usually coming out of the tank. And for ignition, we said it changes 120 volts to 17,000 volts for a spark. 17,000 probably that's the igniters, electronic igniters, and 10,000 to 15,000 that is your regular transformer. Regulator valve that usually opens, it's usually placed after the pump. And if you look in the board now, what does the control do? It turns on the motor, the igniters, and wait 15 seconds, then it turns on the valve. So there's no oil coming into the boiler until you have a valve. Not all burners have valve, this one doesn't have a valve. The new ones usually have a valve. Let me show you the valve. This is your solenoid valve, it's very small. Once you energize it, it will open up the gate. Then once it is de-energized, it will drop back and close. So its default setting, its normal state is what? Closed. If it's de-energized, it will close, it will drop down and completely close. Again, I don't know why we need this information, but just for theory, that you need 30 cubic feet per minute of air to burn 1 gallon per minute of fuel. The idea of this is to understand how much venting you need inside your basement, especially if you have an open burner. It's gonna need some air, right? So if I'm burning 1 gallon per hour, how much fuel do I need? So you can do the correlation here. So if I have half a gallon per hour boiler, probably I will need 15 cubic feet per minute for an hour, minute, hour, an hour. So probably around 15 gallon for the entire hour CFM. So I need to have enough opening for that. That's why, again, it's important to keep your basement, wherever you have your boiler, have proper venting. Otherwise, the boiler is not gonna get enough air.
Is
Yeah.
this supposed to be GPM or GPH?
No GPM, both are in per minute and per.
1 gallon per minute sounds like a
A
lot.
lot, it's a lot. It's not real, but it's just to make the comparison
Okay.
reasonable. So that's why usually the door to the basement has vents in it, so it can pull some air. Otherwise, you might have to do a sealed construction. So a lot of people don't even think about where the air is coming from. Not familiar?
Yeah.
Yeah, we did that last semester. We took apart a burner and put it back again together. And just as a refresher, let's look at the components. And again, at some point you might have to take one apart and fix something, so it's good to be familiar with that. Pump. What is this, Lance? Somebody?
The air intake?
Air intake,
Yeah.
air band, excellent. And what is this?
Coupling,
coupling.
motor
This is
Yeah.
coupling.
Yeah.
So-
The strainer comes here. See this?
Oh, it's in there.
This is the pump. The strainer is in the pump. Nozzle line,
Yeah.
electrodes. What about this?
That's
Diffuser.
Thermolator, whatever that is. Squirrel cage,
Yeah.
inducer fan,
transformer,
transformer.
ordinator.
Where's the nozzle line?
Yeah.
That's where you have a lot of high pressure. And this part connects to this part here. So, what about those?
Those are the
Igniter,
electrodes.
close, insulators.
Yeah.
Your electroid?
Electrodes, ceramic. And where's the cat cell?
It's not
Is
It's not here.
it 11?
Yeah.
11.
No, it's not. It's not. Motor. So this is the basic components of an oil burner without the controls. The controls is what we're doing right now. It will be on the side and it will send power to the motor. It will send power to the transformer, to the oil valve if you have one, which this one doesn't. And that's it. And also the cat cell, which will go here and be mounted to look at the flame at this area here. It should not be exposed to heat, but it should be able to see the flame. If your cat cell is not seeing the flame, it's blocked, it's not going to work. Tanks and piping. I think I will stop here and I will do that